Our next question. Which of the following statements is false for alkali metals? All these while we were discussing about alkali metals, one or two concepts you would have understood. Alkali metals are colored, alkali metals are monovalent, alkali metals can undergo reaction with oxygen to form oxides, peroxides, superoxides. Now keeping these in mind, let's look at these options. Lithium is the strongest reducing agent. Now how do I justify this statement? Alkali metals easily undergo oxidation, thereby they all are good reducing agents. Under that, lithium is the strongest reducing agent. Absolutely right. Sodium is amphoteric in nature. Sodium is amphoteric in nature. We should be aware amphoteric means could react with both acid as well as base. We have never come across this equation. Let us hold this. Alkali metals are monovalent. We have understood this. Alkali metals belong to group 1, only one valence electron. Yes, option C is right. Form hydrides with hydrogen. All alkali metals can undergo reaction with hydrogen to form hydrides. Even this statement is also right. Therefore, lithium is the strongest reducing agent. It's a correct statement. Alkali metals are monovalent in nature. It's a correct statement again. Form hydrides with hydrogen. All alkali metals undergo reaction with hydrogen to form hydrides. Even this is the correct statement. But sodium is amphoteric in nature is not the right statement. Therefore, option B, sodium is amphoteric in nature is the right answer. It doesn't suit as a property of alkali metals. Our next question. The oxides of alkaline earth metal are basic in nature exception to option A barium, option B magnesium, option C beryllium and option D calcium. It's an underlining statement in the textbook. All oxides of alkaline earth metals are basic in nature exception to beryllium, which is amphoteric. Therefore, you got the answer. All oxides of alkaline earth metal are basic in nature exception to beryllium, which is amphoteric in nature. Therefore, the right option and the correct answer is option C beryllium. Few more concepts for you to understand this question properly. Beryllium oxide and aluminium oxide are amphoteric in nature. Understanding that they can react with both acids as well as bases. Again, this beryllium and aluminium can be made passive by reacting with nitric acid. A thin layer of oxide will be formed on its surface, preventing it from undergoing further reactions. Therefore, beryllium is significant. It is amphoteric in nature. And again, you have discussed little while ago in the previous question, beryllium cannot react with hydrogen directly to form beryllium hydride, but it can form beryllium hydride if it undergoes reduction with beryllium chloride in the presence of lithium aluminium hydride. Hope you have understood the concept. Our next question. Zinc reacts with excess of caustic soda to give. Caustic soda is NaOH. When zinc reacts with NaOH, you get sodium zincate. Simple, straightforward answer. Zinc reacts with sodium hydroxide to form sodium zincate. Understanding that in the given options A, B, C and D, option D sodium zincate, therefore option D Na2ZNO2 is the right answer. Understanding this question again. Zinc has the ability to react with sodium hydroxide, I said. Zinc has also ability to react with HCl to form zinc chloride liberating hydrogen gas. From this I understand zinc can react with both HCl as well as NaOH. Similar reaction can also be tried with aluminium. Aluminium reacts with HCl to form aluminium chloride liberating hydrogen gas. Similarly, bauxite is treated with, which is an ore of aluminium treated with sodium hydroxide, that is caustic soda, to form sodium aluminate. Hope you have understood the concept. Our next question. Which member of group 13 does not exhibit the group valency in its compound? Group 13, boron family. +3 is the most common oxidation state. +3 is the most common oxidation state. Other than +3, it can attain +1. But when does it attain +1? On moving down the group, stability of the oxidation number decreases considerably. Therefore, lower down the group, it is +1. Now, which is lower down the group? I have group 13, boron, aluminium, gallium, indium and thallium. So, lower down the group happens to be thallium. It exhibits +1 oxidation state. Therefore, option D, thallium, is the right answer. It can also be attributed to it has got a stable electronic configuration of N-1 D10 NS2. Because of this, it has got +1 oxidation state. So, confirming it once again, on moving down the group, stability of lower oxidation state increases. Thallium is the last member of the group, therefore, it can attain +1 instead of +3, which is the most common oxidation state. Next question. Boron halides are Lewis acids because. So, to answer this, you should be knowing the concept of Lewis acids. Now, boron halides do not easily undergo dissociation to give a proton. Therefore, they cannot be proton donors. Obviously, option A is not the right answer. They are ionic compounds. Boron halides normally form covalent compounds. So, obviously, again B is not the right answer. They do not have complete octet configuration. Option D, have a lone pair of electrons on boron atom. Both are obviously right, but when I happen to single out, they do not have complete octet. They have lone pair of electrons on boron atom. We understand that boron compounds are electron deficient compounds. In this case, option C, they do not have complete octet. Because they do not have complete octet, for the formation of a bond, they draw electrons from the surrounding or from the medium which tries to transfer to it. Therefore, boron halides act as Lewis acids. They are electron acceptor. Therefore, by all probability, the best option would be option C. They do not have complete octet, therefore, they can act as Lewis acids. Option C is the right answer. Our next question, which of the following oxide is acidic in nature? We have here elements of group 13, oxides of elements of group 13. We understand the concept like this. Elements as I move down the group: boron, aluminium, gallium, indium, thallium. Oxides of these elements of group 13 that I have, the first oxide is acidic in nature. As I move down the group, acidic nature considerably decreases, and then the final oxide is basic in nature. Therefore, understanding the concept here, on moving down the group, oxides of elements of group 13, acidic nature decreases, basic nature increases. Therefore, boron oxide is acidic in nature, while the last oxide is basic in nature. The question says, which of the following oxide is acidic in nature? The right answer is option A, B2O3. Boron oxide is acidic in nature. Our next question, what is the basicity of boric acid? Many of them, without thinking, they go for boric acid. Basicity happens to be 3 because it has got H3 in the formula, but it is wrong. The correct answer is basicity is 1. But why it is 1? Let's understand now. I write boric acid as BOH thrice. Boric acid in water, it forms B. Boric acid does not undergo dissociation in water, in aqueous media, but it undergoes interaction with water molecule to form tetrahydroxyborate ion. In this, OH minus tries to contribute electrons to the boron, therefore it acts as a Lewis acid and basicity happens to be 1. This is the reason why the basicity of boric acid is 1. Therefore, the correct answer in this, what is the basicity of boric acid? Option A, 1 is the right answer. Our next question, when strongly heated, orthoboric acid gives. In the previous question, I wrote boric acid formula BOH thrice. It can also be written like this, H3BO3. H3BO3 on heating, it forms HBO2. It loses 2 water molecules. On further heating, this HBO2 will give me B2O3. From this I understand that the final product that I get on heating orthoboric acid is B2O3. The correct answer is option C, B2O3. Our next question is, the chemical name of phosgene is, what is phosgene first of all? Phosgene happens to be the poisonous gas of chlorine. There are three poisonous gases of chlorine. One is phosgene, next is tear gas, and the next is mustard gas. Now, phosgene happens to be COCl2, which is carbonyl chloride. Therefore, the right answer is, the chemical name of phosgene is carbonyl chloride, that is option B. What are the other poisonous gases that you have? Let me try to confuse you by telling phosphine. Phosphine is PH3, which is poisonous gas of phosphorus. It is hydride of phosphorus. Hope you have understood it. Let's look into this question. The carbide which gives ethyne on hydrolysis is, the carbides that we have: aluminium carbide, calcium carbide, iron carbide, and magnesium carbide. Concept is very simple. I'll give you the answer for this. Calcium carbide dropped in water gives ethyne. This is an underlining and a textbook equation. So let me try to explain with the equation. Calcium carbide CaC2 dropped in water, I get acetylene, that is C2H2. Along with that, I will also be getting calcium hydroxide. From this I understand option B, calcium carbide, is the right answer. Now, few more relevant concepts to understand with respect to calcium carbide. This calcium carbide, when I pass nitrogen through calcium carbide, it gives nitrolim, which is a nitrogenous fertilizer. This is calcium cyanamide and carbon. That is, I have, when nitrogen is passed through calcium carbide, I get CaNCN. Along with that, I also get carbon. This mixture is known as nitrolim. Do remember this concept also. Our next question. Which of this can form more than one type of acid in aqueous media? All these oxides of nitrogen have got one or the other significance. If I happen to take option A, nitric oxide is released by supersonic jet. This nitric oxide is colorless. Nitric oxide undergoes oxidation to form NO2, which is reddish brown in nature. N2O3, when exposed to radiation, it changes its symmetry. That is the speciality of N2O3. N2O4, in aqueous media, I write the equation. N2O4 when dropped in water will give me HNO2 and HNO3. It is giving me two acids. One is nitric acid HNO3 and nitrous acid HNO2. So, unarguably option C, N2O4 is the right answer. From this I understand N2O4 in aqueous media gives me two acids. One is nitrous acid, that is HNO2, and nitric acid HNO3. Our next question. Which of this is anhydride of nitrous acid? In the previous question we had discussed that nitrous acid, molecular formula HNO2. Now when I try to write HNO2, X is of it, therefore I am writing. So I remove a water molecule, I get N2O3. Understanding that N2O3 is anhydride of nitrous acid. Option A, N2O3 is the right answer. Now let me try one more option please. By chance if I happen to take nitric acid. Nitric acid, you are aware, molecular formula HNO3. I redo it again, H2 and then oxygen. I remove a water molecule, I understand that now I get N2O5. Therefore, dinitrogen pentoxide N2O5 is the anhydride of nitric acid, while N2O3 is the anhydride of nitrous acid. Hope you understood this concept. Our next question, hydride of nitrogen is basic, while oxides of nitrogen are. Before looking into the option, let's understand the concept. Nitrogen belongs to group 15. All elements of group 15 undergo reaction with hydrogen to form hydrides of the type EH3, where E stands for the element. Now my element here happens to be nitrogen, therefore I get ammonia as the hydride of nitrogen. Unarguably, ammonia is basic in nature, no doubt about this sentence. All oxides of nitrogen that I have, understanding statement, all oxides of nitrogen are acidic in nature, exception to two oxides. One is nitric oxide, that is NO, and other one is nitrous oxide, that is N2O. These two are neutral in nature. Confirming it once again, hydride of nitrogen, ammonia, is basic in nature. All oxides of nitrogen are acidic in nature, exception to two oxide, nitric oxide and nitrous oxide, which are neutral. Therefore, oxides of nitrogen can be both acidic as well as neutral. Now looking into the option, option A only acidic, option B only basic, option C oxides of nitrogen are both acidic and neutral. Option C is the right answer. Our next question, which pair of oxyacid of phosphorus contain pH bond? How to write the structures of oxyacids of phosphorus? Let's try. If I happen to give you H3PO2, I remember it in this concept, P double bond O, necessarily there should be 5 bonds. Therefore, total number of oxygen is 2, used up 1, remaining 1. Total number of hydrogen is 3, therefore I allocate 3. It has got a pH bond. Similarly, understand H3PO3. How do I do it? P double bond O, necessary to have 5 bonds. Total number of oxygen 3, used up 1, remaining 2. 3 hydrogen, 1, 2 and 3. Yes, even this has got a pH bond. Again, H3PO4. Understand? P double bond O, 5 bonds. Total number of oxygen 4, used up 1, remaining 3. Hydrogen 1, 2 and 3. it doesn't have a pH bond. Now looking into the options, I have H3PO2 has got 2 pH bond, H3PO3 has got 1 pH bond. Therefore, that which matches to my option C, H3PO3 and H3PO2 contain pH bond. Next question, which of these contain OO linkage, that is peroxy linkage? What do I have here is, these are oxyacids of sulfur. Option A, H2SO3 happens to be sulfurous acid, H2SO4 sulfuric acid, H2S2O7 is oleum, fuming sulfuric acid, 100% sulfuric acid, pyrosulfuric acid, all are one and the same. Option D, H2S2O8 happens to be Marshall's acid, peroxo disulfuric acid is the right term for it. Now under this, there are two acids which have got peroxy linkage. One happens to be Caro's acid, whose molecular formula is H2SO5, and other one is Marshall's acid, H2S2O8. In the given options, I have option D, Marshall's acid is that which has got peroxy linkage. Therefore, option D, H2S2O8 is the right answer. Our next question, the angular shape of O3, that is ozone, consists of. Therefore, let us draw the shape of ozone molecule. You are aware it's angular, but I write it like this, and you are very well aware its resonance structure would be in this format, where there is a shift in the position of the double bond. Now, how many sigma bonds and pi bonds are there? Understanding that wherever there is a single bond or a double bond, understood that there is a sigma bond. Therefore, 1 sigma, 2 sigma. Therefore, I have 2 sigma bonds. Wherever there is a double bond, understood that there is a pi bond. Therefore, I have 1 pi bond. Therefore, this ozone structure has got 2 sigma bonds and 1 pi bond. In the options, option B, 2 sigma and 1 pi, option B is the right answer. Students, hope you have understood some of the basic concepts in organic chemistry. Though these sessions are given to enlighten you and to strengthen the cord of connects that you have in chemistry, but please do revise your textbook, redo the calculations again and again, look in for the concepts, look in for the notes that you have, and then lots and lots of practice is required. When I happen to look in for oxyacids of phosphorus, you have to do plentiful times the structures again. When you look in for nitrogen or sulfur or any of the compounds, please read through the properties. That will definitely help you to score one or the other marks. And then when you come back to S block and P block, most important is learning the trends as you move down the group or as you move across the period. Learning the trends would definitely help you to score better for your CET examination.